You are now tuned in to the network, the YouTube channel that takes complex networking topics and dumbs it down to a more simple language. Today's topic is compare Cisco wireless architectures and AP modes. This is a topic in the CCNA exam. Let's get right into it. If you look at these images right here, we got several houses right here, right? Now, they all have several things in common, right? They all have a door. They all got windows. Well, not all of them got garages, but most houses have garages like this, right? Well, this is kind of like what we can compare to networks, right? All networks have, networking devices such as switches and routers and things like that, right? But the thing is, not all networks are created equally. Just like houses, the architectures of houses, different types of designs of houses are not the same. The same thing with networks. You can have one network engineer or a group of network engineers designing a network. It's not going to look the same as group B that created a network. They're just not going to be the same. So we're going to discuss the different types of wireless architectures. First, let's talk about the different modes in APs or access points. And we've talked about this in a couple videos back. Can't remember which one, but we talked about how there's a lightweight mode and autonomous mode for access points. Autonomous mode is when all of the functions are within that access point itself. You look at this topology right here. We got the three-tier Cisco hierarchy that we're familiar with, right? We got the core layer at the top, then we got the distribution layer, we got the access layer, right? Then we got the autonomous APs that sits just below the access layer, right? This can be kind of tricky here because I know we said access layer, and this access point right here is connected to the access layer through a trunk. So is it the access layer or the trunk layer? Well, it is an access point, but it connects to the access layer with a trunk. So all of the VLANs are passed through this trunk right here. So essentially the access point is physically connected to this switch right here, and this switch connects to the AP with the trunk right here, right? All the SSIDs are broadcasted with the different VLANs through this access point right here. This is a typical autonomous access point architecture, right? A couple fun facts about autonomous APs. The autonomous AP is self-contained. Just like I said, all of its functions are within that access point, as opposed to a lightweight mode where not all of its features are within that. We're going to talk about where those features are, right, with a lightweight access point. But with autonomous APs, all of its functions are within itself. The radio, the RF management, the packet switching, the broadcasting of the SSID, the associating and disassociating of wireless clients, all of the functions are within that AP, right? Each AP must be configured and maintained individually. Now, just by the sound of that, you can tell that's a con and not a pro, right? Why is that? Because if we have to touch every AP on the network, right? Let's say you got a network that's got a small little business, or I don't know, a restaurant with like 5 APs. That's fine if you need to configure each one of them manually, right? You need to change some VLANs, or you need to change what group that AP is in. Fine, you could do that. You can touch each AP individually because there's only 5 of them, right? But if you got an enterprise network or a large organization like where I work at, where there's like about 6,000 APs or maybe 2,000 APs, it's hard to do that individually to actually, control every AP. This is a con. It's difficult to touch every AP if you've got so many of them, right? Each AP must also be configured with a management IP address, right? I mean, yeah, you can do that with DHCP, but you have to have a separate management IP address for the AP so you can actually control it and configure it and things like that. With a wireless LAN controller, you can control those APs and configure that AP from the wireless controller. We'll talk about that in another slide. Each autonomous AP handles its own security policies with no central point of entry between wireless and wired networks, right? So again, autonomous APs, it does everything not by itself, but you do all of the functions it's contained within that AP. That's why it's called autonomous, because it's like autonomous cars, right? Because everything is done by the car itself. It doesn't need you to drive it. That's why it's called autonomous. The word autonomous means it's like pretty much self-controlled or self-contained. A cloud-based AP architecture is where APs are centrally managed, controlled, and monitored centrally from the cloud. A perfect example of that is the Cisco Meraki cloud solution. You look at this topology right here, we've got pretty much the same thing, right? We got the core layer, the distribution layer, and the access layer, right? Then we got our access points right here, right? So we've got several access points, right? And we have the trunk link, just like in autonomous mode, right? Except we're not touching each of these APs at the access layer, or just even from the access point itself. We're controlling these devices through a centrally managed device over here. It's in the cloud. It's not really a cloud, but it's a device that we say is in the cloud. It's just that we control all of these APs from a dashboard that you could just log into a GUI and control the APs from there, from, you know, right in your cushy office, or if you work from home, you know, on the floor or whatever. Each AP will contact the cloud when it powers up and self-configure. You can configure and manage APs, monitor wireless performance and activity, and generate reports. So it's almost like what I showed you guys in the Cisco DNA video. You can control all your APs, you know, by just logging into a GUI. You can control like the RF signals, you control the RSSI, or not necessarily the RSSI, but how strong the signal is. Change, you know, whether it's a static or DHCP assignment. There's all kinds of things you can do. You would just log into the dashboard and control the APs from a centrally located device, or basically the cloud. Split mat architectures is another architecture. Basically, you take, so you've got, this is one that you normally see in an enterprise environment or a large organization, right? So we have our access point over on this side, right? And then we have the wireless. Now we're introducing the wireless controller, right? But now with the autonomous AP, remember, he controlled all of his functions. Basically everything you see up here: beacons, probe responses, packet acknowledgement and transmission, frame queuing and packet prioritization. You know, you read all this right here. All of that stuff was done on the autonomous AP by itself. But now some of these functions are given to the wireless controller. That's why they call it split mat architectures, because basically they're splitting the labor of media access control layer. So all of these functions are controlled by the AP, right? Beacons, basically like when he broadcasts the SSID, right? Probe responses, packet acknowledgement and transmission, frame queuing and packet prioritization. All of that stuff is done by the AP, but this other stuff is done by the wireless controller. MAC management, association requests and actions, authentication and key management, all of that stuff is done by the controller. Now, you kind of wonder how, like, because really there's a switch right here. This AP is connected to a switch using an access link, not a trunk link, right? So he's connected to a switch physically to an access, using an access port, right? But then how does he talk to the wireless controller? That wireless controller, actually, he might not even be on the same network. He might be, geographically located somewhere else. Well, he's talking to that wireless controller through what we call a catwrap tunnel. And I've talked about this in a couple of videos back. I can't remember which video it was, but basically, it's basically a tunnel that allows the access point to talk to the wireless controller through a logical tunnel, right? He doesn't necessarily have to be in the same building, actually. The AP could be in one building and the wireless controller could be like in another city, really. But he talks to that wireless controller using this logical tunnel called the catwrap tunnel. And catwrap stands for control, I believe it's control and provisioning wireless access points. And it's a protocol that we use to basically use the AP to talk to a wireless controller. Now, I know it says LWAP encapsulation here too, but basically LWAP is lightweight access point protocol. That was like the older version of catwrap, and it was a Cisco proprietary solution. But nowadays you see most wireless controllers and access points talk to each other using a catwrap tunnel. And the catwrap tunnel, within that, they use control messages and data messages, right? As you can see right here at the bottom, control plane is where traffic is used to control and configure and manage AP, manage and monitor the AP itself. Those messages are the control messages, right? Then you have the data plane or the data messages, which is end user traffic, basically the traffic that the end user is sending, right? His emails, his pictures, or whatever the case may be, his porn, that's passing through the AP. That is the data that is done through the data plane. The data plane is in this tunnel right here, and then the control plane or control messages is sent through this tunnel right here. But this is really one tunnel right here. It's just two separate. Yeah, it's two tunnels within the CapWrap tunnel, but one is for control messages, one is for data messages. As you can see, control traffic is traffic that's used to control the AP and stuff like that, and the data traffic, data plane is where the data actually is going back and forth between the wireless controller and the lightweight AP. Remember, this is a lightweight AP, not autonomous. So you see split MAC architecture with when you introduce a wireless controller. And again, we call it split MAC because they split the labor. The wireless controller handles some things, and the AP handles some things. With autonomous AP architecture, the autonomous AP controls all of its functions itself. So now, as our network grows and we add more APs, right, we can have multiple CapWrap tunnels, as you can see here. Shout out to Wendell Odom and the official cert guide. That's where I got this image from. A lot of this material you'll find in that guide itself. Y'all just know I like to break it down in simple language. That's basically what I'm doing here. We're not going to be doing any labs today, just to give you a heads up. I hate to disappoint you if you're waiting on some labs, but in the CCNA objective guide, it says to describe wireless architectures. We don't have to necessarily configure them and stuff like that. Obviously, you want to, you'll understand it better if you actually configure it. But how many of you have a wireless controller at home? But then again, that's where packet tracer comes in. So again, split MAC functions. We split the labor between the access point and the wireless LAN controller. Wireless controller controls the RF management, association and roaming management, client authentication like usernames, passwords, security management, and quality of service. The access point controls real-time functions such as RF transmit and receive, so radio frequencies. When we talk about radio frequencies and stuff like that, MAC management and encryption. So let's talk about the different access point modes. If you're on a wireless controller, you just do configure AP mode and then hit a question mark. You'll see the different AP modes. There's 8 AP modes we need to know for the exam. I know it says REAP here, or REAP, which is Remote Edge AP mode for the Cisco AP. That is not one we're going to cover today. We're going to replace that with another mode, and we're going to talk about each one of these modes separately. So first is local mode. This is the default mode. This is one you're probably most familiar with a lightweight access point. It acts as if the controller and the AP are in the same location, right? It acts as if the controller and the AP are in the same location. Remember, they don't have to be in the same location, but it acts like it. And it sends all of the traffic, controlling data, to the controller. If we lose connection to controller, the access point would disassociate. Will it still function? I don't believe so, because it needs to talk to controller. But that's where you can use another mode, which we'll talk about in a little bit. But again, this is the default mode. The local AP acts as if it's within the same location as the controller. We got our client right here talking to the AP. This AP broadcasts the SSID to him, and then he goes to the controller. Remember, there's a switch right here physically. The AP is actually connected to a switch, and then it talks to the controller using a CapWrap tunnel. Remember that, right? You may or may not need to know those port numbers that I mentioned. These right here are the port numbers. UDP port number 5246, and for the data, it's UDP port number 5247. There's also monitor mode, where the AP does not transmit at all. It basically acts like a monitor. As you can see right here, he just looks for rogue access points, or like basically kind of like hackers, because like a hacker could plug up an AP somewhere and act like it's and it just acts like it's a guest network, whereas some unsuspecting victim can get onto that access point and be like, oh, here's my credit card and my passwords. But an AP in monitor mode, he can detect rogue access points, and then from there you can kind of determine this position of these stations using location-based services, and basically keep your network secure. And that's what AP monitor mode is for. There's also sniffer mode. This is also used for troubleshooting. An AP dedicates its radios to receiving 802.11 traffic from other sources, much like a sniffer or packet capture device. So we got this client right here. You know, he talks to the lightweight access point. Remember, this is a lightweight access point. That lightweight access point broadcasts his SSID. So he goes to the AP, and then to get to the internet, he must go to the switch, which will be located right here. It's just not in here. And then he goes to the controller, and then he goes on to the internet, right? So while the traffic is going back and forth right here, we got Mr. AP right here in sniffer mode, and he is sniffing all of the traffic that's going between the client and the controller right here, right? But then while he's in sniffer mode, he takes all that data, collects it from the controller, because remember that information was going back and forth between the client, this stupid mouse, between the client and the controller right here, right? Back and forth between these two guys. And then he sends it over to the analyzer, which is sitting right here. And AP in sniffer mode does that. You can use, you know, a network analyzer such as Wild Packets, OmniPeak, or I believe MetaGeek that we were using in another video, or Wireshark, where it can be analyzed further. So you can kind of like look at the traffic, see what's going on. Basically used for troubleshooting purposes. Rogue detector mode is kind of similar to monitor mode, right? You're just kind of like looking for rogue APs in the network. And AP dedicates to detecting rogue devices by correlating MAC addresses heard on the wired network with those heard over the air. Rogue devices are those that appear on both networks. So remember, a rogue AP is basically like a hacker just places his AP somewhere and tries to, you know, get some unsuspecting victim's information. Basically, it's kind of like phishing, but with an AP. Y'all know what phishing is, right? If you don't, I'll leave a link in the description below. Shout out to IPWithEase.com for these images. Flex Connect mode, this is one that is very important. We use this a lot of my job right here. It's where an AP is at a remote site and can locally switch traffic between an SSID and a VLAN if its cap wrap tunnel to the wireless controller is down and it is configured to do so. So we got the AP right here. It's a lightweight AP, right? One we're familiar with. Again, now notice they put a switch there because they know it needs to be there. Because the AP is connected physically to the switch, right? But we know he talks to the controller using the cap wrap tunnel, right? But if the controller is down, as you can see with this indicated by this red X here, then we don't have that cap wrap tunnel that we can talk to the controller, right? But we can still talk to this printer right here if this AP is in Flex Connect mode. That's the beauty of Flex Connect mode, because we now don't need this controller to, you know, switch our traffic from wireless to the wired network. When it's in Flex Connect mode, we can, don't get this confused with local mode. Now, as a matter of fact, I remember in a job interview, this guy was asking me a question. He tried to, it was like he was trying to trick me by asking the difference between local mode and Flex Connect mode. The Flex Connect mode kind of like works, it works, you know, switches traffic locally, but it really locally switches traffic remotely, if that makes any sense. Just kind of like look at this image right here, right? You know, normally this AP talks to this controller, but if the controller is down, he can't talk to the controller, obviously. So he's going to locally switch the wireless traffic to the wired traffic, because it's locally switched. This is Flex Connect mode. Very important here. Bridge mode is when an AP becomes a dedicated bridge between two networks. Two APs in bridge mode can be used to link two locations separated by a distance. Multiple APs in bridge mode can form an indoor or outdoor mesh network. So basically you're bridging two networks. That's why they call it bridge mode. We have one network here, and the APs can bridge the two different networks. Flex+Bridge Mode, you guessed it, it's the combination of Flex Mode plus Bridge Mode. The AP can operate in either Flex Connect or Bridge or Mesh Mode. Sometimes they call Bridge Mode Mesh Mode. This AP combines the two. It allows APs in Mesh Mode to use Flex Connect capabilities. I don't have an image for this. Sorry about that, but again, it's the combination of Flex Connect mode and Bridge mode. Hence, Flex+Bridge Mode. SE Connect mode is when an AP dedicates its radios to spectrum analysis on all wireless channels. Log into the GUI, you change it to SE Connect mode, and then acts like a spectrum analyzer. So, you know, you ever heard of use devices like EcoHow, or there's other spectrum analyzers that are out there. Basically, you kind of like analyzing the Wi-Fi traffic, right? But you're doing it with an AP. So the AP is not going to be broadcasting any SSIDs or, you know, associating any wireless networks. It just acts like a spectrum analyzer. Again, you log into the wireless controller, you put that AP in SE Connect mode, as you can, you know, as indicated by this red arrow right here. And then, you know, it basically, you can remotely connect a PC running software such as MetaGeek, Channelizer, or Cisco Spectrum Expert to the AP to collect and analyze spectrum analysis to discover sources of interference. So basically use this to kind of like troubleshoot your Wi-Fi network and stuff like that. That's all I got for y'all today. I know I kind of raced through this information. You know, sorry for taking so long with these videos. Just had lots going on my plate. Got projects and stuff like that on my job. But anyways, that's my YouTube page. That is my Twitter handle. I hope you like this video. If you do, hit that like button. Hit that subscribe button. In other words, comment, like, subscribe to the network.